Hey there, pre-calc friends. This video is for you to get ready for our next quiz on sections 4.4 and 4.5. It's basically going to be a big quiz on our law of sines formula, our law of cosines formula, and then triangle area. So now we're in, let's see how I did that. That was pretty cool. So what we're going to do is we're getting out of right triangle land, and we're going to use these special formulas now for non-right triangles. So the best thing to do is go through the steps that we learned in our notes. What I'll do is I'll go through a couple of these problems together with you and then sort of point you in the right direction of other similar problems. Here's review number one, question number one. This is how it's going to look on the quiz. I'm just going to say solve the triangle. And what we're doing is we're given bits and pieces of the triangle. We need to figure out a couple of things. First of all, which law do we use? So we always try to draw the triangle first. Just make a sketch, determine what case is this. Depending on what case it is, that's going to tell you which of the laws that we're going to use up here on top. Once we know that, then we can just proceed as planned. But then we know from law of sines, if we get that really dangerous SSA, ambiguous case, then the alarms go off in our heads, and we have to watch out in case there are 0, 1, or 2 triangles. So start number one. Number one, I'm going to have B, angle C, and side A. So let me go find a blank page over here that I can draw this out. So number one. Again, first step, sketch it. Let's figure out what case we have. After a while, you might be able to figure this out just by looking at the given information, but it doesn't hurt just to take a peek by drawing it. So we're given angle B, we're given angle C, and we're given side A. All right, so that's two angles and a side right in between. So this would be considered angle, side, angle. Angle, side, angle is going to be always the law of sines. And it's a good law of sines. It's not the ambiguous case, so we know we're only going to get one triangle out. We don't have to search for any more than that. So this is angle, side, angle. All right, our next step is we usually make our little answer box. And since there's only one triangle, we only need to make one answer box. And we'll start to fill in what we know so far. We are given that angle B was 80 degrees. We're given that angle C is 32 degrees. And we're given that side A is 17. And our job is to find these three others. We learned in class that before we even touch the law of sines, we know that we've got one thing we can find right away. Because we know these three angles add up to 180, we can subtract these B and C from 180 and see what we get. And if I subtract that from 180, I find out that my angle is going to be 68. So I'll put 68 in there. Great. Okay. Now, as a reminder, here's your law of sines formula that we have to have memorized for the quiz. And I think we've got this down now. Sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. The best way to use this is just to pick any two fractions at a time that you like, depending on if you have two of the same letter or not. As I look at my answer box right now, it looks like I do have both A's. So I'm going to do a sine of A over A, and then we can just pick and choose whichever angle you want to solve for, or sorry, which side. I want to solve for side B. So if I want to solve for side B, I'm going to use the sine of B over B fraction and combine those two together. Here we go. How about sine of angle A over side A equals the sine of angle B over side B. Side B we don't know. As with law of sines, we learned that the first step after setting up is go ahead and diagonal cross multiply. And I get B times the sine of 68 equals 17 times the sine of 80. And the B is being multiplied by the sine of 68, so we can divide that on both sides. There's a lot of calculator work on this quiz, folks, so just be careful as you plug things in. If things are not working out, remember to add a couple of extra parentheses when you enter into the calculator. All right, I'm going to enter 17 sine of 80 divided by the sine of 68. And I get to the nearest one decimal place, or nearest tenth, which is what we tend to do, I get about 18.1. All right, so I'll put 18.1 in there. Now it's really tempting. We've got two sides. I feel like maybe we want to do Pythagorean to try to solve the other side. But remember, we are not in right triangle land, so I cannot do Pythagorean here. I have to just do another law of sines. But if you notice, if I want to do another law of sines, because it was given, I should still use the A over A, but now I'm going to pair it up with the C over C. So I have this already set up here, and all I need to do is basically swap out angle C and swap out side C, and the rest of it works well. I'm going to write it out though so you can see it. Let's do the sine of, again, A over A equals the sine of angle C over side C. Now we could have used B and B because we have both values, but remember we rounded to get side B. And if we round that, then our answer for side C will be even more rounded. So let's use what was given to us because that was golden. All right, got your cross multiplying. And if it's okay, I'm going to skip a little step here because I think a lot of you are seeing that now. It should be 17 sine of 32 over sine of 68. All right, I put that in the calculator and rounded to one decimal place, I get about 9.7. All right, now are we right? Here's a good thing that we talk about a lot in our class is use a little bit of geometry. Is the largest angle across from the longest side? If I look through, that's my B and B, and yep, they're both the biggest of their own column. And if I want to see which is the smallest angle across from the shortest side, and that's C and C, so that works as well. So that probably is a good clue that you did it right. All right, and that's the answer for number one. Review one, number one, a basic solving the triangle. It was an ASA, so we didn't have to worry about any ambiguous case. Number two is another popular question. We have to find the area of the triangle. And as a quick reminder, remember to find the area, we need SAS case. We always need the side, and the angle in between to use our formula. And as a reminder, here's the formula that we're memorizing. Area is 1/2 a side times another side times the sine of angle C, or the side of the angle in between. So you have your side, and then the angle is what goes right in there. And that's why you need SAS. Do we have SAS here? I don't know. That's again why we want to probably draw it out. So let me make some space here, and we can just make a little sketch and see. All right, here comes angle A, B, C, side A, B, C. All right, we are given side A, side B, and angle C. And once you know, this is side, angle, side. So we're good to go. All we got to do is just plug it right in. Here we go. The area of this triangle, this non-right triangle, would be 1/2 A, B times the sine of angle C. And all I gotta do is just plug that into my calculator right away. I can probably do it in one step. I get an area of about 32.5. There you go. So if we got SAS, we are good to go because we can go right into our formula. If we don't, we have to find ways around it. We might see that pretty soon. And that's review number one. Let's move on. How about review number two? All right, well, we're going to solve the triangle. So again, just like before, let's make our sketch. I'll make my sketch here so you can see it before we flip pages. Okay, according to this one, I'm given side A, side B, and angle A. Now that angle is not in between those two sides, so it's not SAS. And believe it or not, this is the dangerous SSA. So big alarms in your head. Okay, we got to check and see how many triangles we have. Tread lightly. Okay, so no matter what though, it is going to be law of sines. We just have to be really careful as we play with this. All right, let's go find it. Let me get another blank page for you. Do I have space here? I do have a little space. All right. So on this one, we were given A is 23, B is 11, and angle A is 122. All right, I'll make my little table here, box of answers. All right, A is 23, B is 11, and angle is 122. Now, if this turns out to be no triangle case, I didn't really have to make this box here, but for me, visually, I think I just like seeing it because then I can see what sides and what angles are opposite of each other. But if you want to skip this step of making a box until you're sure you have triangles, that's absolutely fine. All right, so I'm using law of sines. It looks like I have the A and the A. And since I have side B, I need to use that fraction to find angle B. Here we go. How about sine of 122 over 23 equals the sine now of angle B over side B. All right, same steps, we're going to cross multiply. And this one gets to be about the same as before, except we're solving for an angle. Now, because we're solving for an angle, we really need to get this sine B by itself. Not just the B, but the sine B. Right now, it's being multiplied by 23. So let me divide both sides by 23. And I get sine of angle B. Notice I haven't put anything in the calculator yet because I'm worried about rounding too early. 11 sine of 122 over 23. All right, now, big star over here. Remember, whenever we're solving for an angle, if you ever need an angle, we always use the inverse button. And here, because we're trying to get rid of sine, we're going to use the inverse sine. All right, so if we take the inverse of both sides, I get angle B by itself is the inverse sine of this huge fraction. Okay, I punched that in, and it looks like for angle B, I get about, okay, inverse sine, punch it in, and angle B is 23.9. All right, that sounds good. I'll put 23.9 over here. Okay, and this is the moment, as soon as you find that first angle, that we stop and we chat about how many triangles do we have. So don't finish this problem yet. It's good to just stop right now so you can see what's coming up. All right, here's that little chat that we talked about before. Here's our little talk. All right, in triangle 1 and maybe a triangle 2, you were given 122 degrees, right? That was part of the given right here. So you're given 122, and what angle did you find? You found 23.9. And is there room in that triangle for another angle? Yes, there is. We haven't bust the 180-degree ceiling, so that triangle exists. All right, if there's a triangle 2, here's the chat. We still have 122. It was given to us. It's starting. It's there. And then here's the trick. We take the angle that you found and we subtract it from 180 to see where it swings into the second quadrant. And if I subtract 123.9 by 180, I get about 156.1 degrees, I believe. Now, in that triangle, is there room for a third angle? And no, you notice that this is greater than 180 degrees already, and that's only two angles. So there's no chance of a third angle. That means there's no chance of a second triangle. So how many triangles? Just one. Yay, that's great. So you only have one triangle to search for. If by chance there was room over here for another angle, then we would have another triangle too. But for this one, no, we're good. So this is an SSA case with just one triangle. Okay, but we have to solve it. We're not done. We have to keep solving for it. All right, I would go over here just like before. You've got two angles. We can easily subtract from 180 and find the last one, and that's 34.1. Great. And then let's just set up another law of sines to solve for side C. So I definitely need this fraction to do C over C. And I can use either B or I can use A, but remember, A was given, so why don't we use A? No rounding there. All right, so when we set that up, law of sines one last time. Sine of 122 over 23 equals the sine of 34.1 over side C. All right, I think we're good to go. I'm just going to jump to where I solve for C. C should be equal to 23 sine of 34.1 over sine of 122. I do not need to find the inverse, folks, because I'm not finding an angle. I'm finding side C, so I don't need to use inverse here. All right, I punched it in, and I got side C is about 15.2. And I'll put that right up here in blue. All right, are we right? Let's do it again. Longest side, largest angle, check. Smallest side, smallest angle, smallest side, shortest side, smallest angle. Yes, yes. So we're probably good. And if we look at the answer key, we do match there too. So there's an SSA case. That's a really good one because we had to figure out there was only one and not a chance for a second one. All right, I hope that one went okay for you too. All right, number 2 on review 2 is another area one. And this one's good just to see if I was to sketch it out. Do we have SAS case here? So we can just use the formula. Let's see. If we do have SAS, I'm just going to skip this problem because it's just like we did on review number 1, question number 2. We were given side B, side C, and angle A. All right, looks like I've got side and a side. Angle in between, yep, it is side angle side. So I just go right into the formula and you're good to go. I'm going to skip that and let you try that one. But another really good one is review 3, number 1. Okay, I'm a little nervous about this one. I think you'll see why. All right, here we go. Review 3, number 1. Let's find a good open page for this one. All right. On review 3, number 1, we were given B is 8.1, C is 8.3, and angle B is 72. We're going to solve the triangle. Which law do we want to use? Well, we don't know until we draw it, sketch it, get a case. Let's go. ABC. All right, I've got side B, side C, and angle B, and wouldn't you know it, it is an SSA. All right, so it could be 0, 1, or 2 triangles, but again, big alarms in your head. I have to watch for that, and watch for that in the quiz. That's usually the biggest mistake that happens every year on this quiz, that we just forget to look for the second triangle, and that means you can miss some really, really big points there. So let's always be looking. Let's nail this quiz. All right, again, I'm going to make my answer box a little early, just in case I need to see what law of sines fractions I want to use. I'm given B is 8.1, C is 8.3, and angle B is 72 degrees. All right, I need to search for. And it looks like I've got B and B, so I'll use that fraction. And I've got side C, so I'm going to use that to solve for angle C right there. All right, here we go. You ready? Me too. Sine 72 over 8.1 equals the sine of this mysterious angle C divided by 8.3. Okay, just like before when we did the one triangle case, we're going to cross multiply, and I'm going to jump way to the end and say that C itself is the inverse sine, right? Because remember, we're looking for angles. We use the inverse sine of 8.3 sine of 72 degrees divided by 8.1. Okay, I punched that in. And once I punch that in for angle C, I get about, let me see, punching in, I get about 77 degrees if I round it. Okay, 77 degrees comes right over here. Now, this is where we stop. Let's have a chat. How many triangles are we going to have? Okay, I'm going to do this one in purple. I haven't seen purple in a while. All right, in triangle 1, remember we were given 72 degrees. You just found 77 degrees. Is there room for a third triangle? For a third angle, I mean? Yes. So that triangle exists. Yay. Okay, triangle 2. We were given, again, 72 is what we started with. We do the 180 minus, and our new angle is 103 degrees. Now, is there enough room after that for a third angle in that triangle? And believe it or not, there is. It's pretty small, but that angle does exist, which means that triangle does exist, which means this is a 2-triangle case. All right, we have to solve for both of them, which means I'm going to have to make another answer box. But that was why. Just a reminder, we used the given. We took 180 minus the angle you found over here, and those two together still make room for a third angle. All right, and that's the talk that we have to have on the quiz to figure it out. So, well, let me just open up another answer box. I've got this one here, or this one over here. The good news is when we have to solve for two triangles, half of the work is already pretty much done for you because the given is still the given. So if 72 was given to you, it's still 72 over here. 8.3 and 8.1. Now, for C, for angle C, it's the other version of this. So over here, when you do 180 minus, do you remember that? That is your new angle C over here. All right, so this other angle C over here is going to be 103 degrees. Right now, why don't we go and solve for angle A and angle A over here, and then we can set up one more law of sines for side A and side A. All right, let's give it a shot. Making some room here. Very good. Well, I know if I subtract over here in the left box, if I subtract from 180, I will get an angle of about 31 degrees. If I do the same thing on the right side, and I subtract from 180, I'll get an angle of about 5 degrees. We said it was going to be small, right? All right, so now to get side A over here, we'll set up another law of sines. I would, again, use the given that we have here, and then this fraction that needs A. And then when you come over to the right side box, I would again use B and B, and use A and A to solve for A. All right, I'm not going to show that because you guys have gotten really good at law of sines, but let me just fill in that if you do it right, side A should be about 4.4 in the first triangle. And then because angle A is different in the other triangle, it should be about 0.7. That's a pretty small side. But look and see, remember geometry? Look how it's across from a really small angle. So that actually makes a lot of sense. But again, should we do that really big geometry check? Take the left box and see, is the largest angle across from the longest side? Yep. Is the smallest across from the shortest? Yep, yep. And over here on the right side box, is the largest across from the longest? Yep. And smallest from shortest? Yep, yep. So that's a two triangle case. Again, this little talk that we have is really, really vital for you to understand that. And that's how we do an SSA with two triangles. All right, let's jump over to review number 4. Doing okay so far? All right, hang in there. You're doing great. All right, solve the triangle. Which law are we going to use? Well, I don't know, so I'm going to sketch it. All right, I'm given here angle A, side B, and look at that, another side angle. Oh, okay, let's give it a shot. Let's see what happens. 0, 1, 2 triangles. All right, well, I see now if I don't want to use the answer box, I can do this visually and just see that I have both letters, uppercase and lowercase. So I'm going to use that fraction of sine A over A. And since I'm given side B, I'm going to use the fraction that uses sine B over B. So let me just jump into that without the answer box so you can see. How about sine of 107 over 6 equals the sine of angle B over side B. As before, we cross, diagonally multiply, and because we're solving for the angle, we're going to use the inverse. So if it's okay with you, I'm going to jump right to the next step and say that angle B equals the sine inverse of 8 sine 107 degrees divided by 8. Nope, I lied. Divide by 6, Mr. Brown. There we go. All right, I punched in the calculator, and guess what pops up? You get this big thing that says error. Now, as long as you did it right and you punched everything in, error means that angle over there you're trying to solve, this angle here, B, is not working out. Maybe the sides aren't meeting each other and making a full triangle. So guess what? That angle doesn't exist, which means that triangle doesn't exist. Now, don't just end with error. That's not a final answer. Your final answer would be there are 0 triangles. And that's your final answer. No triangles or 0 triangles. Don't just stop with error over here. That's great, but you have to interpret your results. So the answer for that one's great. It's an SSA. It didn't work out, so you get 0 triangles. I love that one because it means we are done. Yay! All right, what's happening down here? Looks like we have another maybe angle, side area. Oh, let's take a peek at that one. But just so I make sure, remember finding area, so we need SAS. And if I was to draw this really quick, so I've got angle C, side C, angle A, and yes, in fact, this is an angle side. Okay, but I need side angle side if I want to use my new formula. So in order to do that, it looks like I've got side and the angle next to it. It'd be really good if I could find the side next to that. So I had SAS. So what I mean is I've got this side and I've got this angle. It'd be really good if I could find that side. If I could find side B, then I would have SAS and I could find the area of the triangle. Okay, well, let's see what we got so far. I'm going to make a little box here. That B looks terrible. I'm so sorry. Ah, that's a really good B. I'm not going to lie. All right, so C is 59, A is 83, and side C is 24. Okay, our goal is to get B, because once we have B, then we're going to have side, angle, side, and we should be good to go for the area, right? Okay, so in order to do that, we're going to definitely use, because it's AAS, I need law of sines. I've got this fraction, and I'd love to use this fraction to find B, but I don't have angle B either. Oh wait, but I could do that really quick, right? I've got two angles, I've got A and C. I could subtract that and I can find angle B. And in fact, if I do that, angle B would be about 38 degrees, I believe. All right, now I can set it up. I'll set up a law of sines with these two fractions and solve for side B. All right, side B is equal to, you don't mind, I'm just going to skip a step or 5, and I should get, how about 24 sine of 38 over sine of 59. I'm solving for a side, so I don't need to take the inverse. And if I do that, let me take an extra second and plug that into my calculator here. I've got this sine, I've got this side. And it looks like I got B is equal to about 17.2. Great, okay, so 17.2 goes here. That means I am ready to do side, angle, side. Here we go, area. 1/2 side, and one side could be the 24. The other side can be the 17.2 times the sine of, now it's really important you pick the right angle. The angle here that's in between the two sides is angle A, and that would be 83 degrees. We punch that in, and we should get a pretty good size area. This is review 4, that's right, review 4 number 2. This area should be about 205.3 if we use the nearest tenth. All right, so that's if you have an angle side, but you really, really need side angle side. So just use our law of sines to solve for whatever you need, and you'll be good to go. All right, we have just a couple more minutes left to figure out a couple more of these. We have a law of sines and cosines. We haven't done cosines in a while, so let's see what we have here. Here we're solving the triangle. Let's make a little sketch here. Let's see, angle A, B, C. All right, I'm given side A, side C, and angle B. Oh, that's kind of nice. That's a side, and the angle in between. This is side angle side. Hey, that's a law of cosines. Hey, we like that, right? Because there's no ambiguity here. There's no 0, 1, or 2 triangles. There will always be, always be one triangle left. Yay! So we're going to set up a law of cosines here to try to solve, and I'm going to answer box ready for you in a second. I think this video is going to cut short because we can only do a half hour at a time. So I'm going to pause this video and I'm going to make a part 2. You can jump in on part 2 and we can finish the rest of this problem. All right, see you soon.